Hello everyone and welcome to another episode of Interstigation. In today's episode of Interstigation, we will talk about sine derivatives, finally. And we will be using the two identities that we talked about in the last two episodes. So they are, let's review a little bit, they are the limit as x approaches 0 of sine of x over x is equal to, this is equal to 1, and the limit as x approaches 0 of 1 minus cosine of x over x, that is equal to 0. We are going to use these two results that we got from the last two episodes to find our sine derivative. So our sine derivative, we want to differentiate the derivative of sine of x, obviously. This is our first trigonometric function, so obviously we are going to start with the definition of limits. So the definition of limits is not the definition of limits. The definition of derivatives is actually the limit as h approaches 0 of sine of x plus h minus sine of x over h. And we can use the sum of angles formula to get that this is equal to the limit as h approaches 0 of sine x cosine h plus cosine x sine h minus sine of x over h. And that is equal to the limit as h approaches 0 of cosine x sine h. So we basically get this part out in front. So this part over h plus the rest that we have, which is sine x cosine h minus sine x over h. And if we have that, then we can just simplify it even more. So this is equal to the limit as h approaches 0. So let's separate these using the identity of limits. So that would be equal to cosine x times sine h over h. So this plus this limit as h approaches 0 of sine x times cosine h minus 1. Over here, we basically factor this, and that's over h. And we want to find the limits of that. So that's out of the page. So something like this. And if we have something like this, then notice that this is just our result from over here with actually using h as a variable instead of x. So this part, because the cosine x doesn't have any h related, we can just get it out. So that will be cosine of x times the limit as h approaches 0 of sine of h over h plus the limit as per usual, like we can take this part, this sine of x part out. So that would be, let's actually write it in the second line. So that would be sine of x times the limit. So sine of x times the limit as h approaches 0 of cosine h minus 1 over h. So this is what we have over here. And if we think about it, cosine h minus 1, we can just get that multiplied by negative 1s to get this is 1 minus cosine h. And this part would be changed into a negative sign. And we can apply our two identities over here so that we can get cosine of x minus this 0 times sine of x, so 0 times sine of x, which basically doesn't exist. And our final derivative answer is just equal to, so the derivative with respect of x of sine of x is equal to cosine of x. And if we think about it on the graph, let's think about it on a graph like this, then if we have a sine of x graph, if we have something like, let's say over here, this slope, so this slope is, we said that this slope is 1 from this identity, right? So this slope is simply 1. And if we look at somewhere, let's say here, this slope just looks like 0. And from somewhere, let's say from somewhere here, this slope just looks like -1, and it repeats. So this exactly satisfies our cosine of x, and it is proven both using intuitive sense and rigorous proving with the definition of derivatives. Thank you for watching this episode of Interstigation, and I will see you in the next one where we go over the cosine derivative together. Goodbye.